The universe is a place of unimaginable violence and spectacular beauty. Far beyond our solar system, stars are born, live and die in cataclysmic events that dwarf anything on Earth. These cosmic explosions are engines of creation, forging the heavy elements that make up planets, and us. When we look at the night sky, we're witnessing echoes of ancient, powerful events that shaped the cosmos. These are the universe's ultimate fireworks, reminders of reality's ever-changing nature. Imagine the most powerful explosion you can, now multiply it by 1 billion. That's the energy of a stellar explosion, like a supernova or nova. These aren't just destructive, they drive the evolution of galaxies, triggering the birth of new stars and planets. Understanding these explosions is key to understanding our origins and the universe's future. Recently, scientists watched one of these explosions unfold in real time, revealing how a stellar outburst can act as a natural particle accelerator, far more powerful than anything on Earth. This wasn't just another observation, it was a new chapter in the cosmic rulebook, showing how the universe generates its most energetic particles. This discovery has opened a whole new way of looking at the violent heart of our galaxy. Meet RS Ophiuchi, a binary star system about 5,000 light-years away. One partner is a white dwarf, the dense core of a dead star, and the other is a red giant, a bloated, aging star shedding its outer layers. The white dwarf's gravity pulls hydrogen from the red giant, forming a swirling accretion disk. Over time, this stolen gas piles up on the white dwarf's surface, heating and compressing until it reaches a critical point. Then, a runaway thermonuclear explosion ignites, a nova. It's not as powerful as a supernova, but it blasts material into space at millions of miles per hour, making the system shine hundreds of thousands of times brighter for weeks. RS Ophiuchi is a recurrent nova. The explosion doesn't destroy the white dwarf. After each outburst, the process starts over, with another explosion every 15 to 20 years. This predictability makes RS Ophiuchi a perfect natural laboratory for studying extreme cosmic events. Astronomers know when to watch, ready to catch the next eruption in action. Each cycle offers a rare chance to study the physics of these violent outbursts up close. It's a cosmic time bomb, and we have front-row seats. In August 2021, RS Ophiuchi erupted again, first spotted by amateur astronomers. Their alerts triggered a global response, and telescopes worldwide turned to watch. The nova's thermonuclear blast created a shockwave, an expanding bubble of superheated gas ripping through space. This shockwave crashed into the red giant's stellar wind, creating a turbulent, high-energy environment. Here, particles, protons, and atomic nuclei get trapped and accelerated, bouncing back and forth across the shock front like a cosmic pinball machine. This process, called shock acceleration, is one of the universe's main ways of creating high-energy particles. With RS Ophiuchi, astronomers had a unique opportunity, a nearby, predictable explosion to study in real time. They weren't just seeing the aftermath, they were watching the particle accelerator turn on, moment by moment. This gave them an unprecedented view of the physics at play. For the first time, scientists could observe the birth of a cosmic particle accelerator as it happened. It was a breakthrough in understanding how the universe energizes its most powerful particles. To capture this event, astronomers needed a special telescope, one that could detect very high-energy gamma rays. Enter HESS, an array of 5 telescopes in Namibia, designed to spot these faint cosmic signals. As soon as RS Ophiuchi erupted, the HESS team sprang into action, pointing their telescopes at the nova. They detected a powerful stream of gamma rays, confirming that particles were being accelerated to incredible speeds. This was the first time a nova had been seen in this energy range, a direct window into a cosmic accelerator. The team tracked the gamma ray signal for a month, watching it grow, peak, and fade as the shock wave expanded. It was like watching a movie of the event, not just a snapshot. This time-resolved view let scientists see the accelerator power up and wind down, testing their theories in real time. The breakthrough was made possible by new technology, the ultra-sensitive flashcam camera on the largest HESS telescope. This camera captured faint gamma-ray signals with unprecedented precision. The success was a perfect blend of rapid response, cutting-edge tech, and cosmic timing. For the first time, we had the right instrument in the right place to record the universe's show in all its glory. It's a new era for observing cosmic explosions. The cosmic movie revealed that the nova's shockwave was an incredibly efficient particle accelerator. Protons and atomic nuclei were energized to speeds near light, hundreds of times higher than seen in any nova before. The process matched theoretical predictions perfectly, hitting the maximum energy limit set by physics. It was as if the universe built a textbook particle accelerator, running at full capacity. This is a dream for scientists, real-world data matching theory exactly. It confirms that cosmic shock waves can be as efficient as our models suggest. This gives us a benchmark for understanding more complex cosmic accelerators. The RS Ophiuchi nova shows that even smaller explosions can be powerful particle factories. They might be a more significant source of cosmic rays than we ever imagined. This discovery forces us to rethink the role of novae in the universe. Supernovae are rare but powerful. Novae like RS Ophiuchi are frequent and surprisingly efficient at accelerating particles. If each nova is a potent particle accelerator, their collective impact on cosmic rays could be huge. It's a tortoise and hare story. Many small novae may rival the few big supernovae over time. Understanding particle acceleration in novae gives us a stepping stone to tackle more extreme cosmic environments. The same physics applies to supernova remnants and jets from supermassive black holes. RS Ophiuchi is a clean test case, helping us refine our models for bigger, messier systems. Cosmic rays affect satellites, astronauts, and even life on Earth. Unlocking their origins is crucial for space exploration and understanding our place in the galaxy. This discovery was a global effort, a scientific symphony with every player vital. It began with amateur astronomers, whose alerts triggered a worldwide response. Professionals at Hess coordinated across continents, racing to capture the nova's fleeting signals. The new flashcam camera, years in the making, proved its worth, setting the stage for even more powerful future observatories. This teamwork shows what's possible when curiosity and collaboration unite. From backyard stargazers to theoretical physicists, everyone played a role in capturing this cosmic event. Each discovery answers old questions and sparks new ones, driving technology and science forward. Nova has given us a clearer picture of how the universe builds its most energetic phenomenon. It's a testament to human ingenuity and our drive to explore. As we point ever more powerful eyes to the sky, who knows what secrets we'll uncover next? The universe is full of surprises, and we're just getting started. Stay curious and keep looking up.